Alright everybody, so this is our last lesson of the year. Yay. Today we're looking at composite functions. Fairly straightforward concept. Hopefully it's not too long of a video. So let's look at how this works. So a composite function is basically where you take one function and substitute it in the other function. So example 1 here, let's say that if f of x is equal to negative 4x plus 9, and we have g of x, that is equal to 2x minus 7, let's find parenthesis f, and a little circle here. It's not a dot, it's an open circle. So f of...
I found a few skills that might help.
There's Siri.
Circle of fifths facts?
No.
Okay, how about circle defense?
Siri, stop.
Alright.
Alexa, stop. So f of g and parenthesis of 2. So find f of g of 2, and how this works is whichever comes first, so these two letters here, the f comes first and we have g. Basically we're going to work from the inner letter out. So what we're going to do is take this 2, and we're going to take, since g is the inner letter, I'm going to start with that. So I'm going to evaluate the function g when x is equal to 2. So I have 2 parentheses of 2, close parenthesis, minus 7. That gives me 4 minus 7, which gives me negative 3. So I've taken care of my inner function here, and now I'm going to plug it into my next function, this outer one here. So whatever I get from my first equation, I'm going to take that and I'm going to plug that into my function f. So I'm going to take negative 3 now and evaluate the function f when x is now negative 3. So negative 4 times negative 3 plus 9, that gives me 12. Negative negative makes a positive. 12 plus 9, which gives me 21. So my composite function, f of g of 2, is equal to 21. So that's how you evaluate your composite function. Example 2, let's say if f of x is equal to negative 4x plus 9, and then we'll take g of x is equal to 2x minus 7 again. Let's find g of 1. Now another way you can write this, another way you may see it written, is like this. Just like that. So it's the same concept. We're still going to be working from this function and then substitute that into my second function. But with this one, it might seem a little bit more straightforward because I'm going to evaluate this one and then plug it into my next one. Now, on the previous question where I have f of g of 2, the way I could write that with this type of notation would be f g parenthesis 2, and you're finishing off your brackets. So that's another way that you could write it. So to evaluate this one, I'm going to first again work from the one closest to the number here. I'm going to take g of 1, so I'm going to evaluate the function g when x is equal to 1, and that's 2x, which is 2, 1, minus 7, that gives me 2 minus 7 gives me a negative 5. And then I'm going to move on to my second function, my outer function here. And that is going to give me g. Now I evaluate that function g when x is equal to negative 5. So we get 2 times negative 5 minus 7 gives me negative 10 minus 7 gives me negative 17. So g of 1 is equal to negative 17. Now you can do this as many times as you want. Let's say that I had f of x is equal to, let's say, x squared. G of x is equal to 2x minus 2. And then h of x is equal to 3x squared minus 2x. Let's find g of h of f of 2. So let's go and solve for that one. Now here I'm going to start with the f of 2. So first, let's evaluate the function f when x is equal to 2. So I'm going to be using this function here. That's just going to give me x squared, so 2 squared. That gives me 4. Now from here, my next function that I'm going to be working out to is h. So now I'm going to take this solution I get here and plug that into the function h. So I get h of 4 now. I'm going to substitute wherever I see an x. So I have an x squared minus 2 of an x. So I'll take that 4 and replace my x. So I'll take that x, which was x squared here, and I'll replace it with 4, and that 2x becomes 2 times 4. And that's going to give me, make sure you follow PEMDAS, so I square the 4 first. That gives me 16, so I get 3 times 16 minus 8. That will give me 48 minus 8, which gives me 40. Now last thing I'm going to do, I work my way out to the g, and that gives me g of 40. And now I'm going to take the x, replace it with 40, minus 3, so I get 80 minus 3, which gives me 78. And 78 is my solution there. So you just work on the inner, you're working on the number closest to the number, the function closest to the number, and just kind of work your way out, solving each function and taking that result and plugging it into the next one. Now, we can also solve for where we don't have any variables. So what this means is example 4. Let's say if f of x is equal to negative 4x plus 9 and g of x is equal to 2x minus 7. Let's find f of g of x, or we could write it like this, f of g of x. Both ways work. And remember, I'm not multiplying f times g. I'm not doing that because I have that open circle there. So that's the difference in the notation. So to solve this, notice that I don't have a number. I just have the variable x. So all I'm going to be doing is just doing a simplification. I'm just simplifying the problem. So what we'll do is I'm first going to write it's kind of backwards from the last one, but now I'm going to write the f function first. So I'm going to take f of x, that's this equation here, that's equal to negative 4x plus 9. But the trick is that I'm now going to take, wherever I see my variable x, I'm going to take that x, I'm going to replace it with the function g of x. So that substitution occurs. I'm going to substitute g of x in wherever I see an x, because think about it as when you look at this function here, the f of g of x, this g of x is inside the function f of x. Think about it that way. So you're going to replace the x with the function g of x. So what I end up getting here, when I substitute g of x in for x, what you end up getting is -4, parenthesis, here's my substitution, plus 9, and now I just simplify. So I distribute that 4, that gives me -8x plus 28 plus 9, which gives me f of g of x, which is equal to -8x plus 37. And that is your solution. That's your answer. Example, I guess 5 here. Let's say, we'll use the same equations. Let's say we had f of x is equal to -4x plus 9, and g of x is equal to 2x minus 7. Let's find g of f of x, or we could write it like this, g of f of x. So again, to solve this, I'm going to start with g of x. G of x is equal to 2x minus 7. Now my substitution is occurring with f of x. I'm going to take f of x and plug it in for x right there. So my f of x is that -4x plus 9. So I'll take that, substitute in for my x here, and that will give me 2 parentheses, here's the substitution, plus 9, and now I just distribute and simplify. So -8x plus 18 plus 9. Hold up, sorry, wrote that down wrong. Minus 7, there we go. That's going to give me -8x plus 11, and that is your solution to your composite function. And that's it. So quick review, all you have to do is whenever you take f of g of your variable, or you could write it like this, both mean the same thing, they're interchangeable. All you have to do is take this function, whatever function is given to you, and substitute it into here. You take this function, substitute it in for all the x values here, and then simplify. Now if you actually have numbers, like this, then you're going to take the actual value here, in this case 1, and then just kind of work your way outwards. So first you'd stop at function g, plug it in, solve, whatever value you get, then you take that function, or take that number, plug it into the function f, and then solve. Plug it into g, whatever number you get, take that number, plug it in for f, and then solve. And that is our lecture. And that's it. That's the last lecture of the year. Alright, last thing is that the homework for the piecewise functions and this lesson here, the composite functions, I'm going to make that due Tuesday night, so that'll be tomorrow night at midnight. Both of them will be due. I'll put them both up today, so you can submit them whenever you want, but both will be due Tuesday at midnight, and they'll be our last assignments of the year. But remember, you do have a quiz tomorrow on these functions. I'll probably send out the solutions as soon as possible, so you guys have an idea of what to expect. But yeah, if you have questions, shoot me an email.